Assalamu alaikum, students. In today's class, we will discuss an important phenomena which light undergoes when it enters from one transparent medium to another transparent medium. That is the total internal reflection, because it is based on refraction of light. So in today's lecture, we will begin with the review on refraction of light, and then we will go towards the critical angle and total internal reflection, principle of reversibility of light, because this is an important factor to understand the refraction and to calculate the total refractive index. You know that what is refractive index? It's a ratio of speed of light between the two media, like speed of light in vacuum divided by speed of light in the medium. And the principle of reversibility of light. Beside this, we will discuss some important questions related to GCE O level and IGCSE O levels. So the questions are included here, and these questions are mainly based on total internal reflection. Okay, so our today's class will begin with the review of refraction of light. Critical angle will be the next topic. Total internal reflection, principle of reversibility of light, and relationship between critical angle and refractive index. Then related questions. So this is our today's task. So let us begin with refraction of light. As you have watched my previous video that was on refraction, and this which was followed by dispersion of light. So all of them we'll just have a brief overview. So what is refraction? That is change in the speed of light when it goes from one transparent medium to another transparent medium, because light can travel through transparent medium. So air is one of the transparent medium. It is rarer or lighter medium. When it enters from air to glass or air to water or water to glass, the speed changes. When it enters the denser medium, like from air to glass, its speed decreases. And the direction also changes depending on at what angle it is entering. When it enters at an angle of 0 degree with the normal, there will be no change in direction. But when it enters at any other angle between 0 and 90, there will be change in direction of ray of light in the second medium. Okay, when it goes from rarer to denser medium, it bends towards the normal, as it is shown here. This is incident ray and this is refracted ray. Angle between normal is a line which is drawn at the point of incidence. The point of incidence where the ray is striking the boundary of the second medium. So normal is drawn at 90 degree to the surface at the point of incidence. So the angle between normal and incident ray is angle of incidence. And the ray refracts, bends towards the normal if the next medium is denser, and the angle of refraction is the angle between refracted ray and the normal, and it will be smaller. Like angle of refraction in water will be smaller than the angle of incidence in air. But reverse happens when ray enters from denser to rarer. When it goes from denser to rarer, it bends away from the normal and speed increases. In that case, angle of refraction will be greater. We will have one brief overview on this. Like ray of light enters from glass, air to glass. This is the ray of light which enters from air to glass. This was shown in the slide also. What will be the angle of incidence? We have to draw the normal at the point of incidence. Normal will be at 90 degree to the surface. And this is angle of incidence. This is the direction in which ray is traveling. And angle of refraction will be smaller in the second medium. This. Okay. And this angle is R. Now ray is going from glass to air. Here it was going from air to glass, now glass to air. So this is another point of incidence. Since the two sides AB and CD are parallel, so angle of refraction in the air will again be the same as this angle. Suppose this angle is 40 degrees. This will be smaller, and this angle in the second medium, so in the second refraction, it will be smaller and same, because the two sides are parallel to each other. AB and CD are parallel, so this one will also be 40. Same angle. Air to glass, bending towards the normal, glass to air, bending away from the normal. Now remember, if this is, say, what could be this angle? This angle is 25. So this one will also be 25. Okay, and this is 40. So now the principle of reversibility says what? When ray enters from glass to air, it is striking the glass at 25 degrees. Glass to air boundary, it is striking at 25 degrees. So it is entering the air, it is entering the air at 40 degrees. So here, when ray enters the opposite way, the direction is changed. If it is entering from air to glass at 40, it will refract at 25 degrees. Same angle. Okay. So this is reversibility of light. What is N? Ratio of sine of angle of incidence divided by sine of angle of refraction. So we can say sine 40 divided by sine 25. So if you calculate sine 40 divided by sine 25, what do you get? 1.52 I'm getting. This is the refractive index, no unit, because it is the ratio of the two similar quantities. The other formula for the refractive index is C over V. C, speed of light in vacuum divided by speed of light in the medium. Medium could be water, it could be glass, etc. C, vacuum. Okay, so if you want to calculate, suppose ray is entering from glass to air. How will you calculate the refractive index? Ray is going from glass to air. Suppose the angle is, how will you know the angle? You will have to draw the normal. Suppose this angle is, say, 20 degrees. And it is entering the air at 31 degrees. So how will you calculate? Ray is going from glass to air. So here angle of incidence is 20 and angle of refraction is 31. If I ask you to calculate the refractive index of glass, and you know that the values of refractive index of glass lie within 1.46 to 1.53, it may be 1.6 depending on the type of glass. So if I calculate and use the formula n equals to sine I over sine R, what comes? Sine 20 divided by sine 31. See what answer comes. Sine 20 divided by sine 31. It's coming 0.66. So which is not the refractive index of glass. Okay, so this is giving us wrong answer. So what do? We take it this way. When ray goes from denser to rarer medium, we either write the formula sine of angle in air divided by, or vacuum, divided by angle in medium. So angle in air is 31. Sine 31 divided by sine 20. Now let us check what comes. Sine 31 divided by sine 20. It's coming 1.5. Okay, so this is giving us right answer, right? So either you change the formula a little, you write n equals to sine R over sine I, because ray is going from denser to rarer. Rarer to denser, sine I upon sine R. Denser to rarer, sine R upon sine I. But actually, what is that? The angle in the rarer medium divided by sine of angle in the denser medium. Here, air is the rarer medium, angle in air divided by angle in glass or water, whatever the medium is given. Okay, so this is about the principle of reversibility of light. If light is entering at 20, striking the boundary from glass to air at 20 and refracting at 31, then if a ray of light is striking air to glass boundary at 31, it must be refracting at 20. Okay, so that is why we can take this formula angle in air divided by angle in the medium. Now let us continue our discussion. So this is refraction, and the next slide is related to dispersion of light. Dispersion is a phenomenon which occurs due to refraction of light. Light enters the glass, bends, and splits up into 7 component colors. The videos related to dispersion is already uploaded, and it is in the playlist also. So here, the red color deviates the least and the violet color deviates the most, because refractive index of the medium is different for the colors of different frequencies. All the colors have different frequencies. Red color has the lowest frequency, violet color has the highest frequency. So the refractive index for the violet color is more. It means it will deviate, it will bend the most. And refractive index for red color is the least, so it will deviate the least. Okay, so that is why it is there at the top of this band of 7 color, and violet color is at the bottom. Okay, so this is how the in frequency, these are the colors given in the order of increasing frequency. Red lowest frequency, violet highest frequency. So dispersion occurs when ray enters the prism or the water droplets. Soon after the rain, you must have seen the rainbow colors. Okay. So next topic of this today's class, that is total internal reflection. Here, I have shown you 2 media, water and air. So water is denser compared to air. Okay. So here, there are 5 normals drawn. So it means I will be showing you 5 rays entering at different angles. Okay, since the ray will be entering from water to glass, so it means it will be bending away from the normal. But when a ray enters at 0 degree to the normal or 90 degree to the surface, it does not deviate. Let's see the first ray. It is striking water to air boundary at 0 degree. It is coming along the normal. So there will be no change in the direction of ray of light. It goes straight. Okay, and you can say that the angle of incidence of ray of light is 0, or you can say that it is entering perpendicular to the surface of water. Okay, now let's see what happens to the next ray. It is striking at certain angle, so it will be bending away from the normal. Okay, the angle of refraction in air is greater than the angle of incidence in water. Now, third ray, the angle of incidence is increased more. See that the ray of third ray has more angle of incidence, greater angle of incidence compared to the second ray. Okay, this ray angle of incidence is 0. This is certain angle and this is more. So angle of refraction will also be more. It means when you increase the angle of incidence in the denser medium, angle of refraction in the rarer medium also increases. Now, if you keep on increasing, the angle of refraction will also keep on increasing. So now the special stage has come when the ray has strikes this surface of water at certain angle that after refraction, it is just at 90 degree to the normal. It is just on the surface of the water. So this angle, which it makes, angle of refraction, the ray makes in air is 90 degree. And this special angle for which angle of refraction has become 90 degrees called critical angle C. And this is 90 degree. So here, from here, we get the definition of critical angle. Okay, so critical angle for water is 49 degree. For glass, it is 42. For diamond, it is, because diamond is denser than glass, so the critical angle is 24 for diamond. So 49 degrees. So it means if you increase the angle of incidence more than the critical angle, what will happen? The ray will return to the same medium. It is reflecting. No ray enters the air. So this angle, if it is 60, this angle will also be 60. Or if this is 49.5 for 50, the angle of reflection will also be 50. So it's undergoing total internal reflection at this point. Let us have some definition. What is critical angle? Angle of incidence in denser medium for which angle of refraction in rarer medium becomes 90 degree. What is total internal reflection? When angle of incidence in denser medium becomes greater than the critical angle, the ray bounces back to the same medium. So this phenomena is total internal reflection. Light does not enter the rarer medium. Now, condition for TIR. What does TIR mean? TIR, total internal reflection. Condition 1, ray should enter from denser to rarer medium. Okay, like in my previous diagram, that was entering from water to air. You can have an example of glass to air also. You can have an example of glass to water. Okay, so you can exhibit the total internal reflection in these cases. What is the second condition? Angle of incidence in denser medium should be greater than the critical angle. These are some formula. N is equal to sin I upon sin R, refractive index. When sin angle ray is entering from rarer to denser, sin I upon sin R. And when ray enters from denser to rarer, you will take sin R upon sin I. N is equal to sine of angle in air divided by sine of angle in medium. This is what I just explained. Okay, so when ray goes from denser to rarer medium, you can calculate the refractive index using this formula. N is equal to 1 upon sine C. How we have got this formula? For that purpose, I will just give you some more detail. This was your surface of water, and ray was entering from water to air. Ray is entering from water to air, and it is making 90 degree with the surface. 90 degree with the normal. It is just on the surface. This is 90 degree. This is angle of refraction. And this is angle of incidence. And this is angle of incidence is actually what? Critical angle C. Okay, this is a special angle for which angle of refraction in air becomes 90 degree. Now we will make use of the formula when ray goes from denser to rarer medium. N equals to sine R over sine I. Rarer to denser, sine I upon sine R. Denser to rarer, sine R upon sine I. Sine R here is sine. What is this angle? It's 90 degree with the normal. So sine 90 divided by sine I, which is critical angle. We can write C. Okay. So sine 90 is 1 over sine C. C will be different for different media, like for water, glass, diamond. I am just giving the values of C, critical angle and refractive index. Critical angle for water, 49 degrees, refractive index, 1.33, glass, 42, 1.5, diamond, 24, 2.4. So either you can find out refractive index from this formula if critical angle is known, or if the refractive index is known, you can calculate the critical angle. So because here sine, we can check one of the values, 1 upon sine 42. So what comes when we use 1 upon sine 42? It's coming 1.5. So when you use for water, 1 divided by sine 49, that is giving us 1.325, almost 1.33. Okay. For the diamond, 1 divided by sine 24, it's 2.4. Okay, so these are the different values of refractive index and critical angle, which are not necessarily to be memorized, because one of the two values will be given in the question. Now let us solve some questions related to phenomena of total internal reflection and refraction. So the diagram shows light traveling through a medium. The light reaches a boundary with the vacuum as shown. So it is entering from the medium to the vacuum. The light emerges traveling along the surface. Means it is making 90 degree with the normal. So what is the refractive index of the medium? So if you draw the normal at this point, what is the angle of incidence? And this angle of incidence is critical angle actually. So what could be this angle? This is 90. And this is 90 minus, and this is normal. Normal makes 90 degree with the surface. 90 minus 60 is 30. And n is equals to sine R over sine I. Why? Angle in lighter medium divided by angle in denser medium. So sine 90 divided by sine 30. So this is the answer. So what answer will it be? C, sine 90 over sine 30. The lamp is positioned at the bottom of a small pool of water. The critical angle for light passing through the water into air is 49 degrees. Explain by what is meant by the term critical angle. Critical angle, I just given the definition, the angle of incidence in the denser medium for which angle of refraction in the rarer medium becomes 90 degrees. So here, because it carries 2 marks, so when ray of light goes from denser to rarer medium, the angle of incidence for which angle of refraction in the second medium becomes 90 degree. Okay. Now let us do the other part. The lamp sends light towards the surface of the pool. Figure 2.1 shows 3 rays of light that are at 30 degree, 60 degree, and 90 degree to the horizontal. So they are shown at different angles. On figure 2.1, draw the path taken by each of the rays, 3 rays, after they strike the surface of water. And it carries 3 marks. This type of question we have just discussed. So what will happen to the first ray? It is entering at 0 degree to the normal. So what will happen? This ray will go straight without bending. So this is the path taken by first ray. What about the second ray? What angle it is making? This makes 60 degree with the horizontal surface. You need to draw the normal here. What is this angle? If you apply geometry, this angle is 60. So this is also 60. So 90 minus 60 is 30. This angle is less than critical angle. It means it will refract in air. Okay. And at what angle it will refract? If you may sketch, it will be bending away from the normal. But you know one information. What is the information? The critical angle is given. What is the critical angle given in the question? 49 degrees. It means you can find out the refractive index. N equals to 1 upon sine C. 1 upon sine 49 degrees. So that is coming 1.33. Okay, so refractive index is 1.33. So what will be the angle? You can apply N equals to sine R over sine I. 1.33 is equal to sine R divided by sine 30. This angle of incidence is 30. So sine R will be 1.33 and sine 30 is 0.5. So what comes? 1.33 into 0.5. So that is sine R is coming equal to 0.665. So if I find the angle R equals to sine inverse 41.7. Zero 0.665, that is coming 41.7 degrees. So this angle is 41.7 degrees. If critical angle or effective index, both of them are not known, so you can just revising the knowledge that it will be bending away from the normal. You can just draw it away from the normal and don't mark the angle. Now see the third ray. What is the angle third ray is making with the horizontal? 30 degree. Draw the normal at this point. What will be this angle? If this is 30, this is also 30, opposite. So this one will be 90 minus 30, that is 60. More than the critical angle. Okay, so it means this will undergo total internal reflection. It will come back to the same medium. Now, and this angle will also be 60. Yeah, so this question is done. So we have drawn all the paths. So we have scored 3 marks for each ray. 1 mark for each ray. Now Figure 3.1 shows an air bubble in water. So this is again the example of ray entering from denser to rarer medium, because the ray is in water and it is entering the air bubble. So it's going from denser to rarer medium. The ray of light are incident on the air bubble. The angle of incidence of the ray 1 on the bubble is greater than the critical angle. The angle of incidence of ray 2 on the air bubble is less than the critical angle. Ray 3 is perpendicular to the surface of the bubble. So first ray is entering the boundary of water to air at an angle more than the critical angle. It means the first ray will be undergoing total internal reflection. The angle of incidence of ray 2 is given 27, and angle of refraction of ray 2 in the bubble is 37. Greater angle because the air is rarer medium. Part A says figure 3.1, on figure 3.1, at the point where ray 1 meets the air bubble, mark the normal to the surface, the angle of incidence. So how will you draw the normal here? See, this is the curved surface, and every curved surface is made up of small flat portion. Okay, so it means we have to draw one small flat portion. At the point of incidence of ray 1. That is tangent to the curve at that point. Now at this point, where the point of incidence is present, we will draw normal. Okay. Normal will be 90 degree at the point of incidence to the flat part. Now, where is the angle of incidence? This is the angle of incidence. This is your normal. How will this ray behave? This will undergo total internal reflection because this angle is more than the critical angle they have mentioned in the question. So this will go this way. Same angle it will make with the normal. Now second ray, you have to make another small section, then normal. That is flat portion tangent to the curve at the point of incidence. This is the normal, 90 degree to the tangent. What is the angle of incidence of ray 2? 27. It makes 37 in air bubble, more than the angle of incidence. What will happen to the ray at this point? That will enter the water. Draw the tangent at this point, normal. Now it will bend towards the north because water is denser medium, like this. This is the path taken by ray 2. What about ray 3? Draw tangent. Since this is striking at 90 degrees to the surface, it will go straight. Along the normal it is coming. Complete figure 3.1 to show all three rays continue after they made the air bubble. Now define what is meant by refractive index. Ratio of velocity of light in air divided by velocity of light in water. Calculate the refractive index of water. How will you calculate? Sin 27, angle of incidence, and angle of refraction. So what will you do? Since ray is going from denser to rarer medium. So which formula will you use? Sin R over sin I. Let us check what answer comes. 937 divided by 1.325. Question number 4. This is related to optical fibers. Optical fiber and application of total internal reflection. Okay, optical fiber is made up of two transparent media. One is called core, the inner layer. Two layers are there, inner layer and the outer layer. Inner layer is called core and the outer layer is called cladding. So lighter medium, lower refractive index, denser medium, greater refractive index. So this is cladding. Higher refractive index. It can be 1.6, it can be 1.4. Okay, so ray enters from air to glass, say core. This is normal to the surface. The air is made to enter this way. Say this is laser, red laser. Now this is angle of incidence, I. Now it will bend towards the normal. It is meeting the core to cladding boundary. And this angle, which it makes between the two boundaries, it must be more than the critical angle of the core. Okay, so it means we draw the normal. This angle has to be greater so that the ray undergoes the total internal reflection, reflects back. Okay, here again it strikes core to cladding boundary. So this angle again will be more than the critical angle. So there are chances that it will be undergoing total internal reflection. So it undergoes multiple total internal reflection, and finally it leaves this optical fiber at the other end. So optical fibers, they are lighter, cheap. They are used for medical purpose. They are used for communication because the data cannot be transferred from one fiber to another fiber. There will be no cross-linking, okay, no cross-talk, and it does not catch noise also from the surrounding, whereas copper cable tends to catch the noise from the surroundings, like voice of vehicle, moving vehicle, it can be picked up by copper cables. Okay, so that is why optical fibers are taken their places. Let us see what is asked in the question. Optical fibers are used to transmit telephone signals. Figure 4.1 shows a ray of light that strikes the inside surface of an optical fiber at P. Advantage I have just shown, I told. On the figure, draw a normal at P and mark the angle of incidence with the letter I. State and explain what happens to the ray at P. Use the term critical angle. So what will you do? You will draw the normal at this point, and this angle is greater than the critical angle. So it will undergo total internal reflection. Like this. It's only core shown in the diagram. Okay, cladding is not shown. The optical fiber is made up of glass of refractive index 1.5. At the start of the optical fiber, the ray enters the glass from air. The angle of incidence in the air is 60. Calculate the angle of refraction in glass. Okay, so ray is entering at 60 degrees. Let me take this previous figure. This angle is 60 degrees. So what should be this angle? Okay, so here they have given refractive index 1.5. So n equals to sine I upon sine R. Why sine I upon sine R? Because ray is entering from rarer to denser medium. Sine 60 divided by sine R, and that is 1.5. Sine 60 degree divided by sine R. So sine R is equal to sine 60 degree divided by 1.5. Cross multiplication, sine R goes to this side. So sine 60 divided by 1.5. That is coming 0.577. What is R? R is sine inverse 0.577. Okay, so what will we do? We'll get the angle. That is coming 35.2. So you can write 35. Keeping the same number of significant figures. This has two significant figures, so this also has two significant figures. Okay, so this angle is known to us. And see, you should remember that this angle, which ray makes in air, is also important because the angle at which it refracts, it will enable the ray of light to strike the core to cladding boundary at an angle greater than the critical angle. So this angle is important, and the angle here the ray makes depends on this angle. And which electromagnetic radiations are used used in optical fibers? One is infrared, laser, visible light. Visible light is not preferred because it may disperse. It may show dispersion. So different colors will be obtained here. So the data and the information will not be distinct. Okay, so infrared radiations are chosen and laser monochromatic light is chosen, single wavelength. The white light is made up of 7 wavelengths. So that is why it is least preferred. Now, the question here, figure 5.1 shows a young boy lying on his back on the bottom of a swimming pool. He is holding his breath and his eyes are open. A red light is positioned on the ground at Q. The red light is shown here. And the boy, at first, the boy's head is touching the pool wall. The boy is closer to the pool wall and he is not able to see the light. He notices that as he slides away from the pool wall, his eye reaches a point P where he first sees the light at Q. So figure that shows the position of the boy when his eye is at P. Okay, so you have to draw the ray of light which travels from Q to P. So how the light which is just placed on the surface of the land at point Q will reach the point P. Okay, so here critical angle is involved. See, they say that when the boy was closer to the pool wall, he was not able to see the light because light was not reaching him. Okay, why the light was not reaching him? Because this was red light and it was coming this way along the surface. What angle it is making with the normal? When you draw the normal at the point here, at the boundary, it is the normal. So this ray will enter the point P to strike the point P at critical angle. Okay, so this angle will be C. This is 90 degree. Reversibility, ray from denser medium, when it enters at critical angle, it refracts at 90 degree. The ray coming at 90 degree will refract at critical angle. At critical angle, it will become 90 in air, and coming through air at 90 will refract in the denser medium at critical angle. So it means in order to see the light, boy has to be there at this point. At what point boy should be there? Boy should be here at this point to see the light. Okay. So this was the question. The diagram is drawn here and the ray which enters. So this is the critical angle ray makes. So you have drawn the critical angle is 49. Calculate the refractive index of water. We have calculated these values in the previous parts of the questions. Various questions we have done up till now. This is question number 5. So we have discussed. So 1 upon sine 49 will give you 1.33. So this is the refractive index of water. The red light is now replaced with the blue light. State the effect of this on the wavelength of the light in the air. A wavelength of blue light will be shorter than the wavelength of red light. So refractive index will be greater and blue light will deviate more. It means critical angle for the blue light will be smaller. If blue light is taken, means it may go this way and the boy may not be able to see the blue light. If this is blue light, it will go this way and its critical angle may be slightly smaller. It will be slightly smaller because it has greater frequency. Okay, so the refractive index of the medium will be different for the blue color. Okay, so it is not reaching the eye of the boy. Question number 6. Figure 1 and 2 show rays of light passing through the semicircular glass block of the plastic. Q is the center of the straight side of the block. State value of the critical angle. So which diagram gives you critical angle? Diagram figure 1 or 2? Of course, figure 1. Why? Because the ray is refracting along the surface. Okay, what is the advantage of the semicircular glass block? You use it to study the total internal reflection. Okay, let us read all the parts at the same time. Explain what is meant by critical angle. Definition is already given. Angle of incidence for which the angle of refraction becomes 90 degrees. So 46 is the critical angle. Okay, so what will you write here? 46. Okay, not 40. Okay, when you increase the angle, see this angle is smaller, so ray is refracting. When you have increased the angle, you have made it from 40 to 46, it is refracting along the surface of the glass to air boundary. And what is the advantage of the semicircular glass block? You use it to study total internal reflection, because when you direct the ray of light at any position, but towards the center, where is the center? This point is the center. So when you direct it towards the light from this position or this position, direction towards the center, the ray will go straight. See, here it is not deviating. It's going along the normal. Okay. So in this also, it's making 90 degree with the surface or 0 degree with the normal. So this is the critical angle. And what is the refractive index? You can use either n equals to 1 upon sine C or n equals to sine. What is angle of refraction here? 63 or 27? This is 63. Sine R over sine I. Which one of them is the angle of incidence? 50 or 40? The angle with the normal is angle of incidence. Sine I. Sine 63 divided by sine 40. You will see it gives the same answer. Sine 46. 1 upon sine 46. Let us check. (1.39). Let us check this one. Sine 63 divided by sine 40. It's also giving 1.386, means almost 1.39. So either you use 1 upon sine C or 1 upon sine R upon sine I, you get the same answer. Okay, so if you increase it more than 46, what do you guess? What will happen? If the angle of incidence at the center Q is increased more than 46, so this will undergo TIR, total internal reflection. Okay, let us see what is the next part. Calculate the refractive index. We have calculated. The ray of light strikes the plastic at Q at 60 degree. This 60 degree more than the critical angle. What will happen to the ray of light? It will undergo total internal reflection. So how will this ray of light go? At 60, it is striking, and then it is undergoing total internal reflection. This is the path you will draw. See, the ray is coming along the normal here, so it will go undeviated. So this is the benefit of semicircular glass block. If you shine light here at an angle greater than the critical angle, you will see the light reflecting at this point. Okay. This question is again related to optical fiber. Here angle ray is entering at 50 degree and refracting at 30 degree and undergoing total internal reflection at A. How will you calculate the refractive index of the optical fiber? Sin 50 divided by sin 30. Sin 50 divided by sin 30. Let us see what comes. 1.53. Why rays reflect totally internally reflecting? Because the angle at which it's striking the point A is greater than the critical angle of this glass. What will be the critical angle? How will you calculate if it is you are asked? 1 upon n is equal to 1 upon sin C, and you know the critical angle. You have calculated n. N is 1.53, so you can calculate the critical angle using sin C equals to 1 upon n. This is the value of n for this medium. N. So sin C equals to 1 upon n may be used to calculate the critical angle. Both optical fiber and copper wire are used to transmit data. Let us, we have calculated refractive index. They have asked to calculate the critical angle. So let us solve. Sin C equals to 1 upon 1.53. C equals to sin inverse 1 divided by 1.53. It is coming 0.65. 40.8 degrees. For these type of calculations, your calculator must be set at degrees. This is question number 8. The ray of light PQR. Here you have to calculate X. Angle of refraction in glass is 15. This is 60 and 60. Explain why the ray PQ does not leave the optical fiber at Q. Again, because it undergoes total internal reflection. Explain why the ray QR changes its direction at R. Because now it is entering from glass to air. Glass to air. So this is bending away from the normal. Okay, let me take this figure. Okay, let me draw the direction. The ray goes this way and this way. Okay, so this is bending. The medium is changed. It is entering the rarer medium, that is air. So it bends away from the normal. Refractive index is 1.5. 115 degree is the angle with the normal. Angle X is to be calculated. So how will you calculate angle X? Up till now, the question which we have solved are related to 5054. That is O levels. So n equals to sine R over sine I. Why? Because this is rarer medium, that is air. So 1.5 is equal to sine 15. Sorry. Sine R divided by sine 15 degrees. So sine R is equal to 1.5 times sine 15. Zero 0.258 into 1.5. Sine 15 is 0.258 into 1.5, 0.388. So what is R? Sine inverse 0.388. 22.8. Means almost 23 degrees. The advantage of optical fiber. See, this question has been asked third time in these optical fiber questions. Advantage. Okay, it carries more data, it's greater bandwidth, it's cheaper, lightweight. Okay, and there will be no crosstalk, does not catch noise from the surroundings, etc. Okay, this question is from IGCSE. Okay, this is a box ABCD which contains a prism. In one of the video dispersion of light, I have discussed this type of question in which the prism is, two prisms are placed. This is actually prism periscope. Okay, one ray is given here, drawn. The box contains two identical glass prisms, one of which is shown light incident on prism 1 undergoes total internal reflection within the glass. On figure, complete the path of the ray of light through prism 1. So how will this ray of light go? This will go, this is 45 degree, 45 degree, 90 degree prism. Which type of prism it is? This one. 45, 45, 90 degree prism. So the ray is incident. So this angle, you have to draw the normal at this point. So this angle is 45. This is also 45. This is 90. So this one will be 45. Critical angle for the glass is 42 degrees. So more than the critical angle. So this one will undergo total internal reflection, means it will come back. The other prism is not shown here. You may watch that video of dispersion of light for the answer of this question, but anyhow, I'm solving it here. So what should be the position of the second prism? So that the ray again goes undeviated. It should enter. Means my prism should be placed. I will take the prism. Is this okay? Of course, it will go straight. Okay, then what about the ray of light? Are the two sides parallel? The hypotenuse side should be parallel. So this will be the position. So the prism fits here. Okay, the ray goes this way straight, undergoes total internal reflection, and then comes this. Okay, so this is our answer. Emergent ray. It means position of the prism is important. It should be right position. So we have completed, got 1 mark. On figure, draw a second prism. Inside this is drawn. Okay, select the statement that correctly describe the necessary condition for the light to undergo total internal reflection. Angle of incidence in the glass is less than the critical angle in the of light in the glass. No, it should be more than. The angle of incidence is greater than the critical angle of light in the glass. So this is the right answer, this box. Okay. Then angle of reflection of glass is equal to angle of refraction. No, it's not possible. The speed of light in glass is greater than speed of light in air. Is it possible? No, glass is a denser medium, so the speed of light will decrease in glass. The speed of light in glass is equal, no, not equal. Otherwise, there will be no refractive index. Refractive index of glass to air or air to glass will be 1 in that case, right? So this is also not the right answer. Then what is the right answer? The speed of light in the glass is less than the speed of light in air. So that is the right answer. 2 options, 2 marks. Okay, so you have to tick this box and this box, right? So the questions are done now, and inshallah we will see each other with the next video, which will be again uploaded soon, inshallah. So watch the video and give me feedback. Allah Hafiz.